Optimization problems, part 1. My job today is to give you a plan of action on word problems. So, if up till now you're like, oh, word problems, here we go. Tune in here. With the derivative available to us, there is a set of steps. Unlike word problems in the past where it seemed like, oh, these word problems are coming out of nowhere, I don't know how to get started. This time, you'll know how to get started. Yeah? This title is a fancy way of saying we're going to do word problems. The most efficient way to learn word problems is through example. I can talk till I'm blue in the face about word problems and plans and how to handle things. In the end, just seeing some examples and seeing what I do is the very best way to go. In class, we'll solve the following word problems. Here we go. First one. The local concert orchestra wants to raise the price of season tickets for the year. Currently, there are 760 season tickets holders who pay $200 each. The marketing manager estimates that for every $10 increase in the season ticket price, 20 subscribers will not buy a season ticket. What season ticket price will maximize revenue? Let's leave on the shelf something very important here, which is the math we're about to do here is shockingly close to how they decide the price of things. This new Apple iPhone 12's coming out, and they've set all the prices, yes? They've carefully said, oh, this much for this one, this much for this one. Somebody's gone and done math pretty close to this, not to figure out what the best price is for you. No, to figure out what the best price is that they maximize profits. That's all they're in the business of, is maximizing profits. And the mathematics they did to figure out those prices will be shockingly close to this. One good move in all of these is when you read a word problem like this, don't let yourself get confused. Just look through and look for what they're asking for. The first time through. So let me read it again with that strategy. Local concert orchestra wants to currently, the marketing manager estimates that for every tip the season will not buy a season. Ooh, what season ticket price? What season ticket price? That frames the whole question. When I go to read it again, I know what I'm looking for. I'm looking for a season ticket price. Now, this particular question already has a season ticket price of $200. So let's get that in there right off the hop. So they're going to raise the price. Well, actually, the nice thing about the math here is we might find out raising the price is not the right move. This question assumes that we should raise the price, but it could be, when this all plays out, that the result actually is that we should lower the price. We might get a negative number. So raise it by negative. That won't be that weird, actually. $200 each. Okay, so what I'm going to do is I'm going to write down, let X be the number of $10 increases. So the price is going to increase in increments of $10. So we might go to a price of $7.70. We might go to a price of $7.80. Sorry, of $2.10. We might go to $2.20. We might go to $2.30. Whichever one. This word problem actually is stolen from grade 11. You did this exact word problem in grade 11. You made up this exact same equation in grade 11. And the difference was you completed the square to find the vertex. Yeah? We're going to do better with quadratics. A little better. We're a little better than completing the square. But we'll be ready for anything that's not quadratics. You had to stop at quadratics in grade 11. So, let me write down what some people would argue is the most important equation in humanity for all time, which is profit equals put an either at the end. Profit equals. Now, I'm going to write down for you economics people the whole equation that we don't need today, but I want to write it down so that you're well aware that profit is revenue minus cost. We talked about this with the lemonade stand the other day. Profit is how much money you brought in versus how much money you spend out. Now, they don't really mention about sending money out, but I think there's a rent one in the homework where you'd have to subtract the costs off as well. This one, we'll just talk about the revenue. And where does the revenue come from? It's going to be number of tickets sold times price per ticket. I don't think that's particularly difficult. think you have to be in grade 12 to follow along that the amount of profit they're going to make is number of tickets sold times price per ticket. The profit is the revenue here, so they're saying maximize revenue, maximize profit. Same deal. Okay, number of tickets sold. Last year, they sold 760. I'm going to write that down. 760. And maybe you don't want to write down this line yet until you see everything I'm going to do with it, because I'm going to add some brackets and some adding and subtracting. Last year, they sold 760 tickets, and the price per ticket was 200. Yeah, that was the price last year. Now I'm going to do a whole bunch of stuff to really try and lead you to the equation for this situation. We could add $10 once onto there. One $10 increase. If we do that, the price is going to, or so the number of subscribers is going to, how many do they lose? For every $10 increase, 20 subscribers will not buy a season. So, and if we do that, we're going to lose 20 customers. Or we could do, get my eraser out, maybe what we should do actually is raise the price twice. Maybe that's what we should do. And if we do, we're going to lose 20 customers. Twice. We actually did a word problem like this in grade 9, where all we did was just keep subbing numbers in until it went up, and then it came back down. You did it in my class. And it was fun. You guys played right along. You went 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's the maximum. You know, and that's what we're doing here. Oh, maybe it's 3. Maybe it's 11. Maybe I got to do 11 price increases, and I'll lose 20 customers 11 times. Maybe that's the best one. Maybe it's -1. Maybe it's -2. You see the weakness of this method? We could be here all day trying to find this thing. So we're not going to put 11 in there. We're going to put, maybe you already saw it coming. We're going to put an 11 in there. We're going to put X. Huh? This is the best example ever to show off why we have X out there. Like, why don't we know X? Because we don't know X. You know, our job is to figure out X. We got to put something there to represent the unknown number. There's the profit equation, which is also the revenue equation in this particular case, because there's no cost. I'm trying to teach two examples at once here. This one doesn't have any cost attached to it. When you get to a homework one, all you got to do is put the cost there. You know, so. In grade 11, you'd have to do this, and we're going to have to do it too. Actually, that's not true. You could product rule this thing, but I stick to what I said about the product rule. If it's easy to multiply it out, maybe product rule is more work than you really want there. So I'm going to multiply this out. Profit equals 152 and 3 zeros plus 7,600 x minus 4,000 x minus 200 x squared. And I'll go up here because I'm going to do the rest of the work up here. Here, can you just sit there for a second there? Thank you. Profit equals negative 200 x squared plus 3,600x plus 152,000. Let's just make sure I did all that right. Do I like it? 760 minus 20x. I love that. 200 plus 10x. I love that. 14, 15, 2, and 3 zeros. Yeah, I like that. 7,600. Yep. Minus 4,000. Yep. 3,600. Yep. Plus, yeah, I think I did it all right. 152,000. Good. Now, if you're in grade 11, if you're in grade 11, you'd common factor out the negative 200, complete the square, have to deal with this 150. Oh, it's good fun. Yeah? It was exciting stuff. And you were powerless if the degree changed. If you went to degree 3, you're like, I don't know what to do. There's no complete the cube. You know, what if the power was 2.7? You know, nothing. It's a very specific skill set. It's good for quadratics, but it's not good for anything else. What are we going to do? Oh, okay, here's the most important line of the day. This is the line we want to get to. For max min. Set p prime equal to 0. Well, maybe you're just going to do revenue, actually. Maybe you're going to use an R there because revenue is the profit here in this particular case. But anyways, I wanted to try and handle this two at once. So you take the derivative. And you set it to 0. I'm doing these steps fast because I'm hoping that you'll agree by the time this lesson's over that this part of the lesson is like, yeah, I got that. I'm not worried about that. I can take the derivative and set it to 0. I've done a billion zillion of those. Or I don't find it particularly difficult anyways. Like taking the derivative of a quadratic and setting it to 0, hopefully that's like, okay, I got that. Yeah. There's two things left to talk about after all that's done. The first one is making a final statement about this whole situation, answering the question when it's over. Because 9, it would be easy to now say, therefore the price should be 9. Right? What? Huh? That's why this let statement was such a big deal. I'm making my grade 9s write let statements in all their equations. And they're like, how do we need a let statement? Like as if it's all this work I'm asking for to write a let statement, right? But the let statement's vitally important in all this because when it's all over, after you've done all this algebra, your brain's going to be like, what are we doing here again? Yeah, well, what was I even trying to do here? And the let statement goes, hey, dummy, X is the number of $10 increases. Oh, yeah. Okay, therefore, don't write it yet. All right? But down here somewhere, I got to answer the question. Yes, that's always been true since grade 9. But there's something else I got to do here. See, I know 9 is a critical number. I know the derivative is 0 there. But I don't know what I found. I mean, you may know more about the function itself, and so you know what you're dealing with here. But in general, you won't. If this is a cubic or a power 4, you're like, what did I find here? You found derivative 0. You better make sure it's a maximum. Can you imagine in a real world problem like this? You're like, 9, it's 9. Raise it 9 times. And the owner goes, are you sure? You're like, yeah, 9 times. They go off, and they run the season, raise the price 9 times. The orchestra goes broke because the profits are way down, and they come to you like, hey, what happened? You're like, no, it's 9. Derivative 0. And then you're like, oh, maybe I minimized profits. Oops. Like, it's not like a little error. It's like the biggest possible error you can make is to minimize profits. And a lot of the homework questions you've got, it always works out. It's always what you're looking for because we're giving you basic problems. It's not going to feel like it when you're doing them. You're like, these are not basic problems, but they're basic problems for now, and they're always going to work out. But it is vitally important. Separate mark right here. So after you get this, you got to do this and make sure that what you found was a maximum, not a minimum. It's like forgetting a negative. It's the biggest mistake you can make. It's like, oh, I just forgot a negative. It's completely opposite. Owing me $2,000 versus me owing you $2,000, that's a big, big difference. Where is P prime? P prime is right there. You can use factored form and do the factored version of the tables. That's no problem. You can totally do that. And sometimes that is the better way. I've acted like it's the better way all the time, and that's not true. I was exaggerating. Sometimes you just go, okay, P less than 9, say like a 5, that'll be negative 2,000 plus 3,600. That'll be positive. X greater than 9, say like 20, that'll be negative 8,000, so that's negative. You know what I mean? Like you can just sub in if you need to. But the factor table really works really well for a situation that's got a lot of factors, which this doesn't, you know? So this is increasing, and this is decreasing. Did I find a max? Yes. And lots of the homework you have to do that. But this is such an important step. It's going to get the blood. I'm going to highlight it in blood. Well, that's the eraser. Highlighter, red, big highlighter. The big red highlighter. Yeah? Got to check if it's a maximum. You don't want to minimize profits. You're fired. Yeah? Therefore, the new price should be $9. No, come on. Keep the brain on in the middle of all this. The new price should be, $90. 9 times 10 is 90. Not yet. We're almost there. Price per ticket. It's right there. Here comes yellow highlighting. Just pause for a second, look around, and go, where's the price per ticket? It's 200 plus 10 times 9, 290 bucks. So, unlike other word problems, at the end of this, you got to do two things. Check if it's a max or min, and think about the answer. And make sure you're answering the question. Now, that statement often will help you there. Okay, so as much as word problems are a difficulty, in this particular chapter, there's only so many types of word problems, mostly. About 80% of the word problems are one of the types I'm going to show here, or can be modeled after these. So anyone that comes out with revenue cost, you take out this piece of paper and go, okay, how do we do revenue cost ones? Huh? Here we go. Revenue profit cost ones. Are there any questions about that example? Good. Now, a number example. Just pure numbers. They seem like a joke, but they are really warming up for tougher questions. It's just a matter of manipulating equations. Find two numbers that differ by 15. Also, the sum of 5 times the larger and square of the smallest number is a minimum. These questions are confusing. Here's what I suggest. Don't read all the nonsense the first time. Get your highlighter out and go, okay, here we go. Find two numbers that differ by 15. The sum is a minimum. Now, don't panic to copy things down until you see the big picture here, when you see the big picture developing. If they want the sum to be a minimum, here's my derivative plan. It's the same plan in calculus every single time when you run into a question like this where it says make the sum a minimum. I need an equation for sum, which I'm going to turn into S in just a minute. I'll write sum for there. I need an equation for sum. Then I'm going to go over here and I'm going to go S prime. And I'm going to set that equal to 0. See? These word problems have a skeleton every single time. Make an equation. Take the derivative, set it to 0. This will all be pretty nice if you caught up with the homework at all, because the derivatives here are not nasty. They're pretty straightforward stuff. Now we just need an equation for the sum. That part can be a little bit difficult. I know. I know that. But if we can get that far, the rest will be pretty straightforward. Then after this, we're going to build a little table, do a final statement. It says the sum of 5 times the larger number and square of the smallest number is a minimum. Okay, I'm going to write that down. Let x equal larger number. Let y equal smaller number. So the sum will be 5 times the larger, and say it again, sum of 5 times the larger number and the square of the smaller number. And let me just write that with an S instead. Now, if your brain's been all over the place, or you're still trying to absorb the idea that Mr. Todd got kicked out of high school, this equation is a real problem. Here's why. And it goes back to all that y prime, dy by dx, dy by dt nonsense. The reason it's a real problem is because in this question, we never talked about it at all. I just did p prime. I didn't even talk about what should we take the derivative with respect to. There was nothing to talk about. It was obviously x's. That's what p prime is all about. P prime is like, there's nothing to discuss. Take the derivative. You don't look at it and go, what am I taking the derivative with respect to? It's x. It's got to be x. It's all x's. Got to be. Get to here, 5x plus y squared. Are you going to take the derivative with respect to x? Or are you going to take the derivative with respect to y? This is a major unhappiness problem. Like, as big a sad face as you can do right there, because it's got 2 different variables in it. That's going to cause you a problem, because you don't know what to take the derivative with respect to. In fact, neither will work. Taking the derivative with respect to x will not work here. Taking the derivative with respect to y will not work here as it sits. I've got to do something so that this equation is not both x's and y's. There's got to be some other information. There's got to be some other information in here. And then just scan the question and see what's out there. Find two numbers. Oh, the two numbers differ by 15. Yeah? One's bigger than the other. Oh, in fact, I even know x is the larger number. X is equal to y plus 15. It's got to be. X is 15 times, well, it's the larger one, so it's got to be y plus 15. There might be other ways to come up with that relationship, but the equation's got to be the same every time. You might go x minus y equals 15, same equation. And this is like, this move, again, is going to get the red blood highlighting, like being able to look at that and go, oh, I've got two variables, just a second. It'll be okay, let me look back at the question and see if I can find a way to relate the two variables and make one go away. And so what I get here is s equals 5x. Oh, no, I got x. Never mind. Sub in for x. X is y plus 15. And if you get to here, now you switch that most sad face in the world to the most happy face in the world. Because really, you look at this derivative and you're like, this is where you take a break, you know, watch some Netflix for a while. You're like, oh, I'm in the clear. I am in the, like calculus, like, just relax. I'll take it from here. Thank you very much for the equation, by the way. But I'll knock this thing down the rest of the way. And I'm going to do it fast on purpose. Not to try and confuse you, but to let you know this next part is not a big deal. Here's my fancy sentence, though. For max min, set s prime equal to 0. That's my move. S prime. Really tough derivative here. See how it's s prime again, though? It's back to s prime because you're like, what are you going to take the derivative with respect to? Y. You know, because that's all that's in the equation. There's nothing to talk about anymore. So I'm back to s prime again. S prime equals 5.5 plus 2y. Ooh. Did well. Wouldn't gloves be good? Like Iron Man gloves in this? Like my pen on this finger, highlighter on this finger, eraser on this one. Oh man. I'd be one happy teacher. They'll come up with that the year I retire probably. 0 equals 5 plus 2y. Negative 2y equals 5. Y equals negative 5 halves. Therefore, x equals 12 and a half. Apparently one's negative. Look at that. Who knew? We didn't know. How would you know? And how would you have found this by hand? You would have been like looking forever trying to find it because a negative 2.5 never entered your thinking that it was going to be negative 2.5. Well, let's see how I did convincing you of the important next move. There's 2 moves left to go. What do I do next? Build a chart, yeah. What I found is the derivative of 0. I didn't necessarily find that it was a minimum. And most of the questions in the homework, it works out fine, everything's good. It is a minimum. It is what you're looking for, but it doesn't have to. It could be I found the maximum. All I found was a derivative of 0. Could be a max, could be a min. How do I find out? The chart. Okay, so here's the chart. S prime, I got to look for y less than negative 2.5. I got to look for y greater than negative 2.5. Where's S prime? S prime is 5 plus 2y. And so a number less than negative 2.5, say negative 10, I get a negative. A number greater than negative 2.5, say 0, I get a positive. Decreasing, increasing. Did I get what I wanted? Decreasing, increasing. Was I after a min? Smallest number. Yeah, okay, so this is a minimum. Minimum. Therefore, larger, equals 12.5 smaller equals negative 2.5. Questions here? More time? We're now ready to make a recipe for word problems in this chapter. The recipe is come up with the equation. I'm not saying that will always be easy. I'm not saying that. Then derivative set to zero table. Once calculus kicks in, very prescriptive what you do next. We got to work on making these equations. That's what we got to work on. The rest of it is all going to happen pretty fast. What am I going to do? Love that. What a great feature. This is not too bad. This one's pretty straightforward. Straight out of grade 10, really, I think, actually. A cattle rancher has purchased 5 150-meter rolls of wire fencing to build a rectangular corral. She will use all the fencing. What dimensions will produce the largest area? Here we go. Here's the picture. Rectangle coming up. Rectangular corral. Oh, that's cute. Yeah. Green grass inside. Yeah, it's good. This is as close as I get to doing art. Okay, now, hopefully, after the last example, you get a feel for that 2 variables is a problem. Sometimes we can handle 2 variables. In related rates we could, because it was all d by dt anyways. We knew we were stuck with d by dt. They said that in the question. Here we got to decide, so if we can avoid 2 variables, we'd like to. So here, watch when I'm doing these questions. It's built into me after a million years of doing these. I go, okay, well, 2 sides to the rectangle, x and y. I'm not happy about this situation. So it's in the back of my mind already. At some point, I'm going to have to deal with this because it's not going to work out well. I carry on. I go, okay, well, what they want, largest possible area. So I've got my whole skeleton plan here. You people who don't like word problems, you can skeleton the whole thing out. Maybe cover some of the marks already. Even if you make a mistake on the equation, even if you make a mistake in the equation, you take the derivative, set it to 0, do the minimum, that's totally wrong, you can get most of the marks. Yeah? By showing you know what's going on. Can't get all the marks if you don't know how to make the equation, but don't live and die that. On a test, or assignment, or exam. Yeah, okay. Skeleton plan. Skeleton plan. I want the largest possible area. I need an equation for area. Don't necessarily have to. If you got room on your page and you're all organized and you want to copy this all down, you can, but you might want to wait until I finish because it might not fit where you think it's going to go. And then what's my plan? A prime. Set it equal to 0. Build a chart. Therefore, I'm ready. I know exactly what's going to happen here. And I'm not exaggerating when I say most derivative word problems are like that. Area. I'll do it up here. Area equals xy. What's the problem? We got to hesitate to really make sure we're clear on what the problem is, because xy doesn't seem that bad, but there's a major problem. 2 variables. And then when you get to that moment where you realize, I really want to take the derivative, I really want to say my fancy sentence, but it's 2 variables, then you go, okay, now I'm ready to really read the question. I haven't really read the question yet. The only part of the question I've used is rectangular and largest possible area. That's all I've done so far, and I've got 3/4 of the problem done. No, that's not true. I got the plan completely laid out. I've got to relate x and y. There's got to be a relationship somewhere between x and y, and I look back through the question and find out what the relationship is. A cattle rancher has purchased 5 150 meters rolls of wire fencing. She's got 750 meters of fencing to do this job. 5 150 meter rolls. I hope it's not a big jump to say, okay, 750 total. So, what's the 750 represent in terms of the rectangle? What quality, what aspect of the rectangle are we talking about? Perimeter. The perimeter's got to be 750. So my side equation somewhere, I'm going to put it in the rectangle for dramatic effect here, is 2x plus 2y equals 750. Can you see that in the green? So what I got to do is solve for y or x. It doesn't matter which one. And when I say it doesn't matter, the only time it's going to matter is if you can make your life easier by solving for one or the other. It's symmetrical here, so it doesn't really matter which one I solve for. So a little bit of work here. 2x equals 750 minus 2y. Divide by 2, I get 375 minus y. So I isolate x in there. Sort of reminds you of substitution and elimination in grade 10. Substitution, I guess, specifically. And I bring that in, here, red pen. Yeah? Now I can get rid of the x. 375 minus y times y. Let me just do a little bit better than that because I'm going to stick to what I said. We're not going to do a product rule. If the expansion's pretty easy, you're just making things more complicated than they have to be. If the expansion's difficult, of course you're going to have to do product rule. Here's my fancy sentence. For max min, set A prime equal 0. A prime is, back to blue. Ooh, tough derivative here after everything we've been through, eh? Ooh, 375y minus y squared. 375 minus 2y. Set it equal to 0. This is what I meant about maybe not copying all this down because it might not be in the exact right spot for you. 0 equals 375 minus 2y. 2y is 375. Y is 187.5. I'm going to erase all this and force someone to tell me what to do next, even though I had the whole plan out there. I just don't want you to forget. If you're not a skeleton plan person, I like the skeleton plan at the start, but if you're not that, I've got my answer. I'm feeling pretty good about it, but there's two things I got to do. What's the most important one? I think it's even more important than the therefore statement. What now? Erica's answering. She's already got it on her sheet. Just a step ahead of me. She's like, I know. We got to check. Got to check. Don't minimize the area. You found out the derivative is 0, but we got to know it's a maximum here. So I need x less than 187.5, x greater than 187.5. A prime equal to 375 minus 2y. So less than 187.5, say like 100, that'll be positive. Greater than 187.5, say 200, that's a negative. Did it work? Did I find what I was after? Increasing to decreasing? Yeah, it's a max. And then finally, answer the question. Therefore, the rectangle should be 187.5 by, how do I get the other number? I got the y, 187.5. Josiah? Yes? Oh, yeah, absolutely. Sorry. Totally symmetrical situation, so I didn't put enough thought into that. But he's exactly right. Got my giant eraser here. I put in that table x's when it was actually y's I was talking about. Thank you. I thought he was going to say sub it in because he had his hand up. I thought he was so ready for it. So I already put the arrow. You want to find the other variable? You'll have the equation. It's so good. You already have the equation that exactly tells you because you already used it. And when you put that in, you get 187.5. You get a square. Do you remember this from grade 9? I remember doing this exact problem in grade 9. If you're like, wait a minute, is a square a rectangle? I'm like, yeah, square counts as a rectangle. It's got right angles. It's got 4 sides. It's still a rectangle. Here, the square happens to be the optimum shape. But some of the homework, it doesn't work out to be a square because they have extra sides or less sides. You know, I don't want you to get addicted to squares. It was just fun to go back and do the exact same problem from grade 9. Do you remember it all that time ago? Was it down by the bay thing? You did these dots and you got a maximum? So, a couple people do remember it. Okay, so most of you are like, nah, are you crazy? I don't remember what I had for breakfast this morning. Yeah, meters. Thank you. Good. Other questions? Do I got 2 more after this? A carpenter is building an open box with a square base for holding firewood. The box must have a surface area of 8 meters squared. What dimensions will yield a maximum volume? We're right on top of the type of calculations they do to calculate how big of boxes they'll use for different things, or why the cans are certain shapes and so on. We're right there now, like we're right getting to some real math. But a simple situation to begin with. Open box with a square base. I love drawing these. Here's the box. Here's the box. Oh, this is awful. It's going to be an awful equation that comes up here because it says maximum volume. So if I make the volume equation, x, y, height, it's got 3 variables in it. Maybe you would have used z. I like height because it just keeps me organized to know which way we're going here. I've got to somehow deal with 3 variables now. Apparently there's 2 pieces of information. Brad. Isn't the y also an s? Where are you getting that from? Ah, first piece of information. Square base. Maybe you'd catch that as you were drawing it. Maybe that's not one you would actually have wrote in there. You were like, oh, hang on a second. I know what's going on already. I'll strike it out instead of just erasing it so you can really see what I did there. But this never had to be 3 variables. They said it was a square base. So the volume is x squared h. That's at least a little better. My long-term plan will be to take the derivative of this thing, but it's still too many variables. So apparently there's other information. And that's the first time you really have to go through and read specifically what it's saying in the question and find out what other information there is. It says the carpenter's building an open box with a square base for holding firewood. The box must have a surface area of 8 meters squared. Must have a surface area of 8 meters squared. That's the other piece of information. The surface area, I'll write this in a different color, the surface area has to be 8. So I need a surface area equation. Now for boxes, surface area is not particularly difficult. You just got a bunch of rectangles you got to do, and I'm going to make a little mistake here. I hope somebody catches it. It's not a big mistake, it's just a little tiny mistake. So what are the rectangles we have? We've got a bottom, which is x squared, and a top, which is x squared. So I've got 2 x squareds. And then the sides are all x by h. They're all just xh rectangles. There's 4 of those. So I got 4xh. There's a little mistake. Who can see the little mistake? And it's an easy one to make because they just threw a little something in there just to send me a curveball. Maria? What's that? Yeah, open box. Yeah, there's no lid on it, so I don't need that x squared in there. So that can cause you heartache when you accidentally put that in there. And my goal in this equation is to solve for either x or h. Advanced technique come here. I could also solve for x squared, but okay. X or h and sub it in there. And it doesn't matter which, except one might be a lot easier than the other to solve for, and it could make your life a lot easier. Look at this equation for a minute and think about what it would take to solve for x, and then think about what it would take to solve for h and decide which one is the better choice to solve for. Because in the previous question it was symmetrical, right? It didn't matter. You go after x, you go after y. Which one's the better variable to go after here? Seeing some hesitation. The good news is it doesn't matter that you know. You can try and do both and see. You'll run into some problems doing them. But which one, Will, can you see which one? H is way easier because H is just by itself in one term. Solving for H is, well, it's a little bit bad, but it's not too bad. Move the x squared over and I get negative x squared. H is almost by itself already. So all I got to do is divide by that 4x that's out front. So h is 8 minus x squared all over 4x. And suddenly maybe the derivatives aren't quite as easy as they were before. We're starting to heat up the derivatives a little bit. Oh, welcome. How are you? Then everything must be going perfect. Oh, all right. Have a seat. Welcome. Wow. Shocking. Well, I can't wait to hear everything that's going on. Back to here. What was the plan here? Why did I do all this? What was the point of all this? It's easy to get lost in the algebra and go, what was I even trying to accomplish? The problem I was trying to solve was the fact that this had X's and H's in it. Now I've got this thing, and I like pointing right at it and saying, here, this is what I was trying to accomplish here. I wanted to get volume as X squared times this mess. My writing has gone bad there. Which, boy, that's a quotient rule inside a product rule. Lots going on there. So it's worth the effort at this time just to look at it and say, can I do a little better in all of this? Yeah, can I improve this thing before I start taking its derivative? And I think you've had a bunch of practice at that, seeing different forms of equations. They just threw nasty stuff at you all through chapter 4, right? To try and get you ready for a not bad situation here. You could take its derivative as it is, but we can do a lot better. We could cancel an x here. And so now I'm x bracket 8 minus x squared over 4. Can you see the x that canceled there? X squared out front, I knocked it down to x and got rid of the x in the denominator. Then I could divide both those terms in the brackets by 4, and I get 2 minus a quarter x squared. Hopefully we've learned that a coefficient of 4 is better than dividing by 4. It's a little easier to work with, even though it's a fraction. And then multiply out the brackets and look at this now. That really played out kind of nicely, the way all those pieces fell apart there. Are there other steps you could have taken there? Absolutely. You could have handled that a bunch of different ways. But make the effort to see if you can't do a little better before taking derivatives. Now calculus takes over, right? Our job was to get an equation with one unknown and hand it off to calculus, and calculus would do the rest for us. Because all of that right there is not calculus. Here's the calculus. 4 max min. Set v prime equal to 0, so I go v prime equals 2 minus 3/4 x squared. Set that equal to 0. A little bit of equation solving here. Yes, it's a quadratic. You could definitely quadratic formula it or something like that. But since there's only one x, you can actually just isolate here, even though it's an x squared. How am I doing here? I'm talking while I'm doing it here. I don't know why I put the root there. I'm ahead of myself. I saw the squared coming. I got excited. X equals I'm going to write the plus minus for a second, then I hope we can all agree that plus minus is not a thing here. Yeah? So here comes the plus minus. I haven't forgotten about it. I just, in the middle, went, come on. I need minus there? Well, why? It's a box. You're not going to build sides of negative. What? That doesn't look, okay, we don't need minus now. So don't ignore the plus minus. Just make sure in your head you went, I know why we don't have a plus minus here. Listen, no carpenter ever. You're not going to walk up to any carpenter ever. We're going to get some wisdom about fractions here. Yes, plus or minus 8 root 3. Maybe even plus, root 3 on the bottom. The top is 2 root 2. Rationalize the denominator. Yeah, I get all that. But you're probably not handing that off to a carpenter. Yeah? Carpenter probably wants the decimal. So there are times in life where you go, yeah, I think decimal is going to be fine here. So we'll switch over to decimals here. Square rooty. Where's my rooty button? Square rooty 8 over 3 equals, see, it wants to do it, 2 root 6 over 3. Imagine going to a carpenter and say, okay, I need a box for firewood. I need the side length to be 2 root 6 over 3. And you're like, you're an idiot. All right, 1.6. 1.6, what is it? What are we working in? Meters. Two things left to do. One is to check if I've maximized volume. So I need my V prime chart. X less than 1.6, X greater than 1.6. V prime. This is a tough V prime. Look at that. No, factoring is going to help you. Factoring chart is necessarily going to help you or anything like that. You can't just really look at it and get the answer. You're probably stuck with just pure subbing. You know, I just take that, a number less than 1.681 and sub it right in here. So I get 2 minus a quarter. That's positive. That's good. Sure glad it was positive. That's good. And then x greater than 1.68, like a 5. I got 10 minus 125/4, something big. You might actually have to go through the subbing and everything like that to be able to handle that situation. And so what I get here is a max. Thank goodness, a max. Not my max. Well, thank goodness, he's cooking the tacos tonight, so thank goodness for max. But that's not the max I'm talking about, I hope. I hope. That's not why I named it that. I use his nickname. I call him Maximum, don't I? Buttercup, what do you need? Forever. Like probably 18 more years, right? We talked about this. No, I'll pause right after this one because they want to go on the break. I'll finish the last example. So I'll be done in 2 minutes here. And that's all in the video. What's up, Buttercup, on the video? You'll be showing that to your mom tonight. Here, listen to this. All right, focus. What's the last thing? Got to do it. Got to do it. Answer the question. You know, when it's all done, you got to answer the question. Therefore, the box should be 1.6 meters by 1.6 meters. Those are the x's, yes? Back to my diagram, 1.6 by 1.6. Then I need the height, which is just sub it in. And the nice thing about these questions is that it'll be a nice sub. There'll be an equation somewhere that's like, here, me, sub into me. I'm looking for h somewhere here. I took to the habit of putting boxes around this one, that isolation one, because I knew I was coming back to it at some point. I waited here so you can see why that box is nice. It's like shouting, here, sub into me. So here is fraction button, 8 minus 1.6 squared, all over 4 times 1.6. I typed it in right? Oh boy. I can't read that at all. Maybe I'm not reading all weekend. I get 0.85. Anybody else with me? Veronica's nodding. By 0.85 meters. What questions do you have about that example? We're going to take our break in just a minute. I'll do the last example afterwards. I don't know what I'm going to do about the second lesson. I'm not going to worry about it until later. You guys know. Questions here. What questions do you have? Besides like, wow, they are starting to heat up a little bit. Yeah, I tried not to make it out like, oh, word problems are going to be so easy. They're not going to be so easy, but there will be a plan of attack here. Get an equation with one variable, take its derivative and set it to 0, so you can build your table and make your conclusion. All in one sentence there. Questions? More time? Who needs more time on this slide? I got to be careful with this question because it's awfully tempting to say, this is my favorite word problem. It's my favorite. And when I say that, I've tried to trigger you that when I say things like that, you're like, oh, here's one for the test of the assignment. And I don't know that I'm saying that because I haven't really worked on your assignment yet. But I like going to this one. It's like a 50-50 chance. This one or another one, by the time the chapter's over, I'll go to because I really like the cone because it brings in some stuff. And there's some deep understanding to be had about cones. That's not that difficult, actually. It's not that difficult when I actually do it, but this one brings it up. Cindy makes a candle holder by inscribing a cylinder in a right cylindrical cone. What? The description is like, good luck. I got to draw it once and then describe it, and you go, oh, now I get what you mean by inscribing. And then it's worse. I got to draw this thing. Good luck, Mr. Todd. Here we go. That's the print. That's the fill. Do I remember? I need an oval over here. Oh, not bad for me, actually. Everything was great except the thickness of it. I need it thinner. Oh, yeah, I like it. Then I need straight lines. Straight lines. You tell me when I'm done if you're like, yeah, cone. Great job, Mr. Todd. For you. For me, this is pretty good. Oh, it's really good, right? Good luck me drawing that. You should do this on the chalkboard, yeah? There's the cone. Now, the only thing I'm going to do, because now I'm remembering what has to happen next, to really see this well, I'm just going to make the cone a little flatter like that. It doesn't really matter that I did that. It's just going to be easier in the picture if I do that. Next, it says inscribing a cylinder in the cone. So there's a cylinder inside the cone, and I'll describe how that's a candle holder in just a minute. And so now I'm going to switch over to the candle holder, and the candle holder maybe should be orange and all that. You let me know how I do here. And orange, white, yes, that's good. Candle holder. See how I do here. Extend that out a little bit. Grab that. And where's the duplicate? Duplicate, yeah, there we go, okay. Move this up, where's it? Ooh, woo! Ooh. Oh, I don't know. Actually, if I get this the first time, I'm actually maybe going to do a little dance. Oh, that's not what I wanted. Straight line. Yeah, straight line. You know what? I'm sorry. If you look at that and you're like, it's a terrible picture, that's about 98% for me. That is absolutely beautiful, showing what's going on. Two things I want you to understand. One is that's a cylinder inscribed inside a cone, and it's a candle holder. Here's the deal. You can hang this beautiful decorative cone on your wall, and you can slide a candle down inside, so it's got a burning candle on there. Yeah? Cindy makes a candle holder by inscribing a cylinder in a right cylindrical cone. By right cylindrical, they mean it's just straight up and down like this. They throw that right word in there so you know everything's straight up and down. That is, this cone is like, it's right angled. It's symmetrical. The height of the cone is 15. Well, let me just write that on there. Height of the cone is 15. That's 15. The radius is 5 centimeters. So my picture isn't very accurate here, but I made it very flat, the cone, so that you could really see the cylinder in there. I think that was the best way to draw it so I could see it. Bye. Thank you. Good. Okay. The height of the cone is 15. The radius is 5. Find the dimensions of the cylinder that will maximize its surface area. The surface area of the cylinder. I've got a surface area maximize. Okay? So I've done all that reading, drawn a picture, and in the end, I'm ready for my skeleton plan. Let's go back to that. Over here, carefully written. Surface area of the cylinder. See, this question's awful because cylinder and cone both start with C. I can't just go SA with a little C down there. I got to really nail this thing down. So surface area of the cylinder, my goal, find an equation for surface area of the cylinder. Maybe you don't want to write all this down yet. Surface area prime, set it to 0. Little table, little therefore statement. Yeah, this is everything that's going to happen here. And the good news is the surface area of a cylinder, in this course, we actually give you the formulas you need. So when you're doing the homework, I hope you learn the formulas. I hope you know how to find surface area of a cylinder, because it's not particularly difficult, actually. This is how we make cylinders. Cylinders are rectangles. That's what they are. They've just been rolled up, that's all. Circle on top, circle on the bottom, and a rectangle around the outside. You know, pretty simple shape, actually, when you put all the components together. So the surface area of a cylinder is made up of, and I'm going to pause here, and I hope you pause with me when I write it. There's a moment I'm going to write something. I'm going to turn and look at you, and I hope you know what's going through my mind. Okay. Surface area of cylinders. 2 pi r squared. The two circles, yes, top and bottom circles on the cylinder, plus that rectangle, which has its length is the circumference, times the height. Everything was good till the end. It's a beautiful equation. Easy to take the derivative of, easy to sub into, all that stuff, but what's its major unbelievable drawback in the situation we're in and what we're trying to accomplish here? Simon. it's got an extra variable. Now, that's going to be the difficulty here, is you're going to write this in original equation, you're going to have your plan, and at this moment is the first moment I really got to read the question carefully. All I took out of the question the first time was, okay, cylinder and a cone, which before I taught it here, it might be like, I have no idea what you're talking about, but now you see what cylinder and a cone means. And that I wanted to maximize surface area. That's all I took out of the question the first time. Now I got to go back and read because I got R's and H's. Some relationship between the radius and the height of this thing. I got to add something here. This is the radius of the cylinder. This is the radius of the cylinder, and this is the height of the cylinder. In fact, I'm going to totally rewrite that line very carefully because of the cylinder cone thing that's going on here, that they're both C's. Written carefully, surface area of a cylinder is 2 pi times the radius of the cylinder squared plus 2 pi times the radius of the cylinder times the height of the cylinder. My job, find a relationship between the radius of the cylinder and the height of the cylinder. Get ready. Make that a little bigger. This is a nominee for the toughest 2 minutes so far, I think. You know, the algebra's tough, I get that, but that's really about practice. This is the toughest conceptually. Here we go. Right here, I'm going to put it on my diagram. There's radius of the cylinder right there. Right here, height of the cylinder, and it totally looks impossible. How are we going to get a relationship between the radius of the cylinder and the height of the cylinder? My job is to say and do something that allows you to go, oh, I see it here. Brad's got his hand up. Did I make a mistake, or do you have an idea, Brad? He sees similar triangles, and he's totally right. And somehow, between me and Brad, we got to come up with enough information here to go, there's 2 triangles here. Yeah, that's the big thing about similar triangles. When 2 triangles appear, that's when you sort of know similar triangles is coming. When there's only 1 triangle, it's Pythagorean theorem, or it's sine cosine, maybe tan. You know, when it's only 1 triangle. But apparently Brad sees 2 triangles, and you might not even see 1 triangle here. Describe where these triangles are, Brad. Yeah, the full cone. Okay, that was one we were supposed to get some work done in grade 9, is getting used to the idea. What color, what color, what color? Ooh, pink? No. Purple? Green. Supposed to get used to the idea that right down the center of a cylinder is a beautiful right angle triangle. That was supposed to come off a bunch of times way back in grade 9. I don't know. It might not have been enough practice. It might have been too early, you know, to see that every time you got a cone, you've got a triangle pierced right through the center of it. Where's the other one? Down here. And those 2 triangles are similar. That is, and because the similar triangles aren't always taught the best, I'll teach similar triangles a different way, which is if I went down to this angle here, that angle's in both triangles. And so the ratio of opposite over adjacent would be the same in both triangles. The tan of that angle has to be the same no matter what triangle I use. So those 2 have to be the same. Is it enough? There's 2 ways to set up similar triangles. I always go with the sides of the triangle I'm working in. I go, listen, 5 over 15, that ratio has to be the same as the one in the smaller triangle, that ratio in the smaller triangle. In the big triangle, 5 over 15 in that triangle has to be the same as, ooh, what's this? This is the easy one. In this triangle. It's one of the things I want. It's so good. Radius of the cylinder. But the other one is not. And we need another. I think I've got all the information there to get the other piece there. Let's just make sure. I'm going to highlight the sides I'm using in the big triangle in yellow. I'm using this over this. In the small triangle, I highlight in pink, I'm using this over this. I've done radius of the cylinder. Now I need this side here. It's there. There's a way to get it, but it's not simple. Maria? 15 minus the height of the cylinder is what's there. Yeah. Woo! Hey, I got to my thick pen there somehow, and I don't want that. We talked about Coke earlier, eh? Having some Coke for breakfast. I can't believe I had a pop for breakfast. There is another option. Like I'm starting to run out here. There is another option. Just have another one for lunch. You know what I mean? It's awfully tempting to do. Like I'll just power back up again for a little while. You know, I don't know. It makes for a long night. You know, all right. I don't know what's going on. Oh, I knew what's going on here. Let's rewind. It's easy to get confused in all these things and go, what am I trying to accomplish? I had an equation that radius of the cylinder, height of the cylinder, and I can't take the derivative of that easily. It would be nice if I get rid of one. Now I've got an equation, and actually once you have this equation, there's some work to be done yet, but all I have to do is solve for either radius of cylinder or height of cylinder in this thing. Which one's going to be easier to deal with? Well, they're actually pretty similar, but there's going to be an easier one to sub into. Would you rather sub into the R, or would you rather sub into the H? To me, the H is a little easier to sub into, because I don't have to square it and everything like that. But again, both will work. So my goal is to go solve for height of cylinder. I'm going to do all the steps, and then I'll stop for questions. Let's see. 75 minus 5 times height of the cylinder equals 15 times radius of the cylinder. I'm not doing a good job of making those look like subscript. Yeah. Negative 5 height of the cylinder equals 15 radius of the cylinder minus 75. And so I get height of the cylinder equals negative, I'm going to reverse that at the same time, not to mess you up, but just so you see the beauty of this. 15 minus 3 radius of the cylinder. How'd I do? Look, I just did it again to make sure. What a mess. What questions do you have? Question? It's weird. Your hands seem to have a question. Your hand's like, what the heck is he doing? Other questions? Simon? I cross-multiplied, moved things around. There were some other choices there. I could have gone some different steps there, but that basically shows the steps there. What was I trying to do? What am I trying to accomplish with all this? I've now got height of the cylinder. It's going in there. And in the middle of that, I'm ready to drop the little cylinder notations because I'm now all cylinders, things. So the surface area equals 2 pi r squared plus 2 pi r 15 minus 3r. And just tidy that up a little bit. 2 pi r squared plus 30 pi r minus 6 pi r squared. I like drawing a line under that because now my thinking has changed. I've got this beautiful equation for the situation. Just multiplying it out in my head again just to make sure I didn't make any little mistakes there. 15, 30 pi r minus 6 pi r squared. It's beautiful. Do a little tidying on my page here. Get a big eraser out. draw a nice thin line down here and say, okay, this is my last phase. Take the derivative. Ooh, I could have done a lot better with that surface area equation, couldn't I have? You see the like terms there? I could have combined 2 pi r squared and negative 6 pi r squared. I've got a negative 4 pi r squared, and I would have got negative 8 pi r. But it's okay. It's all good. Negative 8 pi r plus 30 pi for max min. I know in the other examples, I put this line before I did the derivative, but it doesn't really matter where I put this line. What's left? Like nothing. I got nothing left. You've been teaching for 3.5 years here. I shouldn't think that's funny, but I do. Right. Well, what's next? Tell me. What's next? What do I gotta do? Find the height is one of the 3 things I have to do. Something else? Make sure it's a max. Don't want to minimize. I'm supposed to minimize. And then finally, answer the question. Yeah, okay. So I'm going to do the chart first. Very small here. R less than 3.75. R greater than 3.75. SA prime. Use your SA prime equation. I think I might have pointed at the wrong equation when I did this a minute ago. Less than 3.75, say 2. Negative 16 pi plus 30 pi. That's positive. Greater than 3.75, say 10. That's negative 80 pi plus 30 pi. That's negative. Oh, good. It's a max. That's good. And so, therefore, the radius is 3.75 centimeters, and height is, it's out there somewhere. Sub into there. 15 minus 3 times 3.75. It's 3.75. Isn't that weird? I don't want you to think in general it always works out to be the exact same number, because it doesn't have to. It just happens to be in this situation. Maria, question? Yes. You have to use the endpoints. It actually goes back to an absolute maximum in question and say, okay, if it's not at the where the derivative is 0, it must be at one of the endpoints of the situation. This particular question would be hard to come up with endpoints because it's a continuously moving situation. So a question like that would probably say, okay, find the time between 2 and 8 seconds where we're at a maximum. You'd find 5, which is a minimum, and you go, oh, it can't be 5. It must be at either 2 or 8 because it's a minimum in between, and you try the endpoints. So that ends up combining the methods we did yesterday with absolute max mins with this. So that's when that comes up. And I got to say, it could come up in the homework. You let me know as soon as it does. Well, for the most part, you get what you want out of this. And if you don't get what you want, it's because you made a mistake, not because there's essentially a problem with the question. The questions we're doing mostly will, the equation we'll have a max, and we'll find the max. If we're looking for a max, and what we find is a min, it means our maximum must have been out at an endpoint somewhere, okay? So it's only one level deeper, but you don't see it a lot here. Good question. Other questions?